Hello all. In this section, we are going to learn about the addressing modes of 8051 microcontroller. The 8051 microcontroller supports 5 addressing modes: immediate addressing, register addressing, direct addressing, register indirect addressing, and index addressing mode. Before we discuss any further, let us find out what is meant by addressing modes. Now, the addressing modes can be defined as the method by which an instruction finds its operand. Now, let us consider an example instruction: add a, b. Now, this is an instruction for performing addition between a and b. Now, how to find the data a and b? This a and b is otherwise known as the operands. Now, there are different methods by which an instruction can find its operand. Now, 8051 supports 5 addressing modes or 5 methods in which they find its operand. Let us consider one by one. To start with, immediate addressing mode. In the immediate addressing mode, the operand is present within the instruction itself. Now let us consider an example: add a, #77. Now this instruction is read as add a, immediate 77. Now the meaning of this instruction is that the first operand will be present in a, which is our accumulator, and the second operand is 77. That is, the data is given directly in the instruction itself. So the data can be directly collected from the instruction and the arithmetic operation specified herein can be completed. So this is immediate addressing. That means the data is immediately available in the instruction. Moving on to the second method of addressing the operand, register addressing or bank addressing. Now in register addressing method, one of the general purpose register will be used for storing our operand. So we have general purpose registers R0 to R7. Now these registers can be used for storing one of our operand. Now consider the example: add a, R0. So it means that one of our operand will be stored in register R0. So for completion of this instruction, we have to get the operand from register R0. Other operand will be present in the accumulator. Both has to be added together. So here the point is that the data will be residing in one of the register. Third addressing mode, direct addressing. Here, the address of the data is directly available in the instruction. Our operand will be stored in a memory, and that memory location's address will be specified in the instruction. Now consider the instruction move a, 088H. Now the address 88 is the location address of our operand. So here the instruction will find the operand from the memory location 88 and the operation will be completed thereafter. Moving on to the next addressing mode, register indirect addressing. In register indirect addressing, once again we are making use of the general purpose register R0 or R1. These two registers are used for storing the memory location's address. So basically what the instruction has to do is that it has to refer the register R0 or R1 to collect a memory location address from where the data has to be taken. So that means the registers do not provide the data directly, but it provides us with the memory location address of our operand. Now to indicate this indirection, the instruction will be written like move a comma at rate R0. Now at the rate symbol here indicates that the R0 do not contain the data, but it has a pointer that points to the memory location where the instruction can find the actual data. So let us read the description. The address of the data is available in the register R0 or R1 as specified in the instruction. So that's about the register indirect addressing. So directly we don't get the data, but we get a memory location address from where the data can be collected. The fifth addressing mode, indexed addressing mode. Now this is somewhat similar to the previous one, indirect addressing mode. The similarity is that we have to find the address of the operand, and using that address we have to go to the memory location from where we have to fetch the data. Let us consider the instruction move C a comma at the rate a plus dptr as our example. Now in this instruction, dptr will be a memory location that will contain a base address. It is a 16-bit register in the CPU, and this will contain a base address. And A is the accumulator that is going to contain an offset value. So for finding the data, we have to add these two contents together. That means the offset value in accumulator plus the base address in dptr. Their sum will give us the address of the operand. Or in other words, I can say it provides us with the effective address, the addition of offset and the dptr. So using the effective address, I have to get the data, and that has to be used for completing the operations set in the instruction. So here again we are using indirection, but we are performing an addition so that we get the effective address. So let us read what it says about move C a comma at the rate a plus dptr in this slide. So the 16-bit register dptr and the register A are used to form the address of the data element stored on a ROM chip. So this is about 8051 microcontroller, and C indicates that it's the code memory or it's the program memory. And our last slide is an introduction on the grouping of instruction based on the operation each instruction is performing. With regard to 8051 microcontroller, it supports 111 instructions in total. And based on the operation each instruction is performing, we can categorize the entire instruction into 5 groups. Arithmetic instruction, logical instructions, data transfer instruction, Boolean variable instruction, program branching instruction. Now the details of this instruction we will discuss in the next class. And if you have any doubts with regard to what we have discussed so far on addressing modes, you can comment in the comment box. Your queries will be answered. Thank you for the patient listening.